Have you ever stopped and wondered what is actually going on inside ChatGPT when you ask it a question? Well, today we're going to pull back the curtain. We're going to demystify the so-called magic behind these incredible AI chatbots. You know the feeling. You type a question into this little box, and out comes this coherent, sometimes brilliant answer. It really does feel like magic. But, of course, it's not. It's an incredibly complex process that we're about to unpack together, starting with the very first ingredient, just a mind-boggling amount of data.
So here's the plan. We're going to build a large language model, an LLM, from the ground up, step by step. And by the end of this, you'll have a really solid mental model for how these things actually think.
Okay, so everything, and I mean everything, starts with data, a truly colossal amount of it. The journey begins by just scraping huge, huge portions of the public internet. To give you a sense of scale, a common starting point is a data set like Common Crawl, which has indexed over 2.7 times billion individual web pages. But you can imagine, the raw internet is, well, it's a mess. So to make any of this data useful, it has to go through this intense filtering process, kind of like a giant funnel. First, they filter out all the spam and malicious sites. Then they have to pull the clean text out from all the messy code. After that, it's filtered again for high-quality language, and finally, they do their best to scrub out any personally identifiable information. So after all that super aggressive filtering, a good representative training data set like one called FineWeb might end up being around 44 terabytes. Now, that sounds huge, right? But here's the crazy part. You could almost fit that on a single modern hard drive. We've basically distilled the pure chaos of the internet into this one concentrated library of high-quality text. Now, before a neural network can actually read any of this text, we have to convert it into a language it understands. And that process is called tokenization. We're essentially breaking down all the words and sentences into a fixed vocabulary of smaller chunks. You can think of these as the atoms of language that the AI is going to work with. And this right here reveals a really critical trade-off at the very heart of how these models work. See, we could represent text as a super, super long sequence of just zeros and ones. But instead, tokenization gives us a much, much shorter sequence to deal with in exchange for having a larger vocabulary, about 100,000 unique symbols or tokens. And this is absolutely key for making the whole thing efficient. So we have our 44 terabytes of clean internet text. And now it's all been converted into this massive sequence of about 15 trillion tokens. So, what do we do with it? Well, this is where the real training begins. You know, for all the talk about complexity and AI consciousness, the goal of this first massive stage of training, it's called pre-training, is almost laughably simple. The AI is given a sequence of tokens, and it's asked over and over and over again to do just one thing. Predict the very next token in that sequence. That's it. This all happens in a continuous loop that just runs and runs. The model gets some text, it predicts what token should come next, and it calculates a probability for every single one of the 100,000 possibilities. Then, and this is the important part, it compares its guess to the actual next token from the real internet text. If it was wrong, it slightly adjusts its billions of internal parameters to try and make a better guess next time. And it does this trillions of times. I absolutely love this analogy from the AI researcher Andrej Karpathy. He says to think of training as twisting billions of knobs on a giant DJ set. Each tiny adjustment tunes the model, helping it slowly discover a configuration, a setting that perfectly matches the statistical patterns of human language it saw in all that training data. So after months of this training, costing millions of dollars in computer power, what do we actually have? We have what's called a base model, and it's not a helpful assistant yet, not at all. What it is an incredibly powerful internet document simulator. It has learned the patterns of text so well that it can generate brand new text that looks and feels like it came straight from the internet. So how do we get from that raw, powerful simulator to a helpful assistant that we can actually have a conversation with? Well, that brings us to the next critical stage, fine-tuning. And the shift from pre-training to fine-tuning it's dramatic. First, we basically throw out that massive internet dataset. Now, we use a much, much smaller, custom-built dataset of just a few million ideal, high-quality conversations. And the goal is no longer just predict the next word of the internet. The new goal is predict the next word of a helpful assistant.
And this is a very human-driven process. I mean, companies literally hire armies of human labelers and give them these super detailed instruction manuals on how the assistant should behave, be helpful, be truthful, be harmless. These people then sit down and write thousands and thousands of perfect example conversations, showing the AI exactly how to respond. The base model then just continues its training, but now on this new, perfectly curated data. So it's this fine-tuning stage that really transforms the model from that raw internet simulator into the helpful conversational assistant we all know. Now, it's really important to get this. The fine-tuning stage doesn't teach the model new facts about the world. All that knowledge is already baked in from the pre-training. This step just teaches it a persona, a conversational style. But this is also where some of that classic AI weirdness, like hallucinations, comes from. For instance, if you ask a model about a person who doesn't exist, like Orson Kovacs, it might confidently invent an entire biography. Why? Because it's just imitating the style of an answer, and in its training data, questions that start with who is are almost always answered with confident facts.
And this gets to the very heart of how an AI knows things. You can think of it as having two types of knowledge. The knowledge that's stored in its billions of parameters is like a vague recollection, a fuzzy statistical summary of the internet. It's like a fact you vaguely remember reading a month ago. But the information you provide in your prompt, the context, that's its working memory. It's sharp, immediate, and directly accessible. Hallucinations happen when the AI relies too heavily on that fuzzy, vague recollection.
This also explains another fun little quirk. How is it that an AI can explain the mind-bending complexities of quantum physics, but then it often fails at a task as simple as counting a bunch of dots?
It's because it isn't seeing an image of dots like we are. It's processing a description of them as a sequence of tokens. And here's the kicker. It has a very limited amount of computation it can perform for each new token it generates. It simply can't do all the work of counting in one single go. To solve this, it has to be taught to reason step by step, or to use a tool like a code interpreter. It literally needs more tokens to think.
So when you see these quirks, the hallucinations, the simple math or spelling errors, they aren't just random bugs. They're direct side effects of how these models are built. They're statistical parents trying their best to match a pattern, and they have this finite computational thinking space for every single step they take. So, with all that said, understanding this kind of quirky mind is really the key to using these incredibly powerful tools as effectively as possible. So, what's the big takeaway here? Well, first, remember, they are statistical systems, not all-knowing oracles. Think of their knowledge as a compressed kind of fuzzy zip file of the internet. Their personality? That's learned purely by imitating humans. And, most importantly, you will get far, far better results if you provide key information in your prompt, giving it that working memory, and ask it to think step by step. And that leaves us with a pretty big final thought. These models are built by compressing and statistically reflecting this vast, messy ocean of human text we've put on the internet. So when we look into that mirror, at its knowledge, its biases, its creativity, what does that ultimately tell us about ourselves?